Hey folks, first of all, mic test, mic test. Folks, can you guys confirm whether my sound is coming properly? Cool, sound is okay. Yeah, chalo, I think दो चार मिनट wait करते हैं for other folks. But like meanwhile, like write in chat, like how was the contest, like how many you sold and overall like your contest was difficult, simple. How was your contest? Give me like some feedback overall. Abhijit, will start with first only, yeah, matlab, because like some people want some question, some want some. But yeah, relatively, like we will try to spend more time on the difficult problems, basically, and naturally also like that will happen because like difficult problems will have like more concepts which we can discuss. Avinash, no worries. Like you solved one, that is great. Have a goal key maybe by the end of the month. If you can solve two, that would be pretty awesome. So we'll wait for like 4 or 5 minutes. Tab tak yan, let me to print the message and reply to the chat. At 10:40 we will start. Why did you solve E at last? So I was not getting it, like what should be the construction. Like the G2 was like I felt G2 was simpler for me compared to E. But yeah, at the end it was like relatively very simple construction. सर सी प्रॉब्लम का एक ही अप्रोच था क्या? Yeah, we need to think actually. Like there is one approach which is very simple and that I also used. I fearless coder. ये वाले का टॉपिक बताओ please. So yeah, for D there is not much of a topic. It's you can say permutation is one topic, but you don't really need any specific knowledge to solve it. I mean, like if सर एक भी नहीं हुआ my fifth contest, हम होगा don't worry, that is okay, that is okay. Like we will start with first one, so like try to understand as much as you can, and like now after the contest, after basically understanding the stream or from the explanation, try to solve like first or second yourself also. Up solving is the most important thing. Like that's where your progress happens. Up solving is most important. So like let's say you solve three, try to solve fourth. If you solve two, try to solve third. Similarly, unless you have solved everything, that is great. But otherwise, try to solve the next one for sure because that is the most important part. Sir, I did only A. That is fine, Kappan. Yeah, in last 20 seconds, what the idea of C, my network sucks. Yeah, that happens. Like sometimes you get the idea like 2 minutes before, and sometimes you get like 2 minutes later, like, after the contest. Can we solve G1 using try? I will need to think about it. Basically, I solved it using like LCP array, which is like a Z function basically. Z function is a standard algorithm which calculates this LCP array. But yeah, I'll need to G1 KM period. Basically, I did all five. Great. I saw A to F first time. Awesome. D DP का था क्या? No, for D, like we don't really need DP actually. I'll just solve two questions A and B. Okay, yeah, let's wait for 1 more minute. Then we will start. Cool, let's go. Also, this is like first live stream of like editorials. So कोई technical glitch आए तो yeah, let me know. Hopefully, like next time, I'll figure out like more about the tech, how to show like screen in better way, all those things. Could only solve two, which is great, yeah. Aman, like you could solve two in your first ever contest. That is pretty awesome, to be honest. Okay, I think let's get started. इसकी recording मिलेगा please. Yeah, I think if you have exam tomorrow, that is fine. But generally, like whenever you do a contest, right, try to absolve maybe same day or next day. So yeah, that should be the goal. By कोई भी नहीं मिला. Abhinav Gupta, no worries. I'm I'm pretty sure like you're just starting out. So how the tension मतलब please tell Cindy. Okay. Yeah, let's get started. Let me also try to share this. Can you guys see the whiteboard and whatever I'm making there? Yep, yep. Okay, awesome. Cool. What do you mean by upsolving? Upsolving means that solving contest problems after the contest, which you couldn't solve in the contest. So let's say like you solved four, then try to solve fifth after the contest. All right, let's get started. We look at first problem first. Okay, so first problem is telling us maximize, right? So we need to maximize this function, and basically x is given and the y have to be less than x. So yeah, constants are important, right? So in general, like time limit is 2 seconds. So in general, most platforms in 1 second you can do up to uh, close to 10 to the power 9 operations, but which means like very small operations. Plus is also an operation. So 10 to the yeah, just below 10 to the power 9 is a good approximation. So let's say you have a linear time algorithm, then 10 to the power 7 would be fine up to the. Okay, so the main thing is that x is 1000, right? So I mean, if we try every possible value of y, then we just need to try 1000 value. That's it. And our test cases are 1000 only, right? So let's say if we try every possible value of y, so like what we'll do, let's say value of y is 5, then we will find the GCD of 5 comma x, and then plus the value of y, which is 5 for our scenario. So like for one value of y, we can test this, right? So basically like which we do. So like we can simply do this for all possible values. X is just 1000 and y would be less than that. Yeah, so that's it. But what will be the time complexity, which is a critical part to judge whether our solution will work or not. So it will be 1,000 test cases, and then for every test case, we are trying 1,000 values, and then like GCD calculation will take some time, which is log of the value we are finding GCD of. Y is also Y can also be 1,000 at max. So it will be 10 to the power 6 into log Y. In general, like I was saying, right, 10 to the power 8 complexity would be fine in most platforms for like 1 second time limit. For the folks like who are very new to GCD, so like GCD basically means like greatest common divisor, which the problem also tells us. Is the first one clear to everyone? Yeah, for me, I think you read the question wrong. So like in question, it's given GCD x comma y plus x, not x comma y plus x. Log y पे कैसे पहुंचे? Are you saying about the time complexity? So basically, like that is the time complexity of GCD. So like that much time GCD takes basically. So there are 1,000 test cases, Abhinav. If you look at the problem here, yeah. So look at the problem here. In total, there are 1,000 test cases, which means like 1,000 times you will give an x and you have to print the value. So you can see 7 here. So 1,000 multiplied by for every case, you have to take care of 1,000 cases. Correct. For C++ folks, you can directly use this function also. All right. So basically, let's say like you have a machine, like you have a computer, right? So generally, like I was saying, in most of the platforms, in 1 second, you can do up to 10 to the power 9 operations, which is like 10 to the power 8 in terms of time complexity, because generally, like you would be doing many small operations, like reading something or doing some calculations. So that's the link between the time complexity and the number of seconds. So like number of seconds is the time which your program will be allowed to run on the platform's computer. And if the program doesn't finish within 2 seconds, then we are done. Can you please show the code for it? I can show the code for it, but like, uh, do people want to see the code in general for all the problems? Yes, the live stream will be present. Yeah, so I don't think lot of people would want. I think probably some people want. What we can do is like first let's get to the algorithm of everything. In the end, if you folks want code of something, then we can show the code, because in general understanding is important. Okay, let's get to problem B. And after all the problems, we can do actually like some sort of Q&A for like specific question. Let's say you are stuck in one problem, then we can discuss like up about that in more details, because in the end everyone is seeing it. So yeah, I'll share the link of all the problems actually. Cool. So for this problem, all right. So this is basically saying we are given two strings, and it is asking us we want to find the longest integer k, which is a so prefix of a and subsequence of b. So subsequence means that we can skip some values in b. Okay, let's look at the solution for this. All right, so we have a string a. Okay, let me take the question. So in general, let's say for simpler problems, right? Simpler problems generally, like even if you don't use the most optimized version, they works because that's the point. They are simple problems. But as you go to harder and harder problems, so like the time limit will be like very constant. Then like if you can't find the most optimized version, then that won't work. And yeah, but like you guys know, like we are doing this like summer camp, right? So like things like GCD and all, and I mean, if these are the kind of things like maths and all, these things we will be covering in that. I mean, this is the explanation like stream. So like we can't really explain like sort of like code for GCD because I mean, at some point we have to assume like some common knowledge. Okay, so yeah, for this problem, we have two strings. Let's say first string is P I O T E C F, and then string B, which is A B B C I O. So in the end, what we have to do is that we want to find the longest prefix of it, which is present in this as a subsequence. Subsequence means, let's say we want to find the longest prefix, right? So first we will search the first index. Okay, first character. Where is P? P is here, so P is found. And then we'll see I. I is here. O. O is here. F. I mean, like F is in the end. So let's say T. Then there is no T after this O, right? So like we could only find PIO, three elements. That's it. So the answer for this would be three. So the algorithm would be straightforward. What we have to do is that we can keep two pointers. First pointer will start from here. Let's say first pointer will start from this index, second will start from this index. At every point, we want to find the where the first pointer is, because the goal is to find minimum maximum length prefix from the A, right? So what we will do is that we will try searching for P in then. Okay, we compared it with A, it's not there. Then we increase the second pointer in this direction. Then we compare P with B, it's not there. Then we go to third element. Now we can see, all right, P is equal to P, right? Now we can see P is equal to P. So we increase the second pointer, but we also increase the first point because one element we found. Now we will try to find the I. Similarly, when we go to C, okay, I and C are not equal. We are here in this string, we are here. Then we go here, and now we can see, okay, it was I, it was I. So we increase the first pointer again. That's the goal. So in the end, when we reach the second string will get finished, and then we will see, all right, we have just covered three elements of the first string. That's where the answer is. Okay, let's go to the C one. Hopefully, like most of you would have solved it already, or otherwise would have understood it. Okay, so in C, you can give any possible solution. Multiple solution would exist in this. So it's possible that your solution was like very different from mine. But let me tell you like what my solution was, and let me try to share like how I got sort of idea of this solution. All right. So in B, time limit won't exceed because we are in every step we are increasing string B pointer by 1, right? So in the end, maximum time it will take is the length of the pointer B, length of the B string. So that's why time complexity will be linear. Like it will be O of M in at max case. Okay, so let's go to C. Hmm. All right. Like I guess most of you would have read the problem. But yeah, so my main idea came from this, that X is right. X is only 500. X is just 500, and AI we can have up to 10 to the power 9. Let me tell how it gave me the idea of like how we can build it. So let's say one general thing before that, like in all the programs, like I will try to share some general concepts also so that it can be useful for you in general in solving other problems rather than just talking about that specific rule. So let's say if we have X, right, and if we do mod X, which means taking remainder of X. So no, let's say we are taking it y. So like doesn't matter what y is for any number, this will always be between 0 to x minus 1. That is true, right? Because that is the point of the remainder. If it's more than x, then we will just divide it one more time and the remainder will be between 0 and x minus 1. So solution of what I use is that, let's say we start with a1 is equal to 1000. Then when we go to a2, so let's say if x2 is anything, it's like let's say k. What we do is that we just do 1000 plus k here, and we just keep on doing that. 1000 plus k, 1000 plus k plus, let's say x3 is y, or then we will do 1000 plus k plus y. Why does this work? Like we showed, right? Because the maximum limit of k and y is 500. So it is 1000, and it is 1000 plus k. So it will be less than 2000, obviously. So like whatever k is, or you can see in this way also actually. Let's say we have 1000 plus k and we take remainder of it. 1000 remainder, 1000 is 0. K remainder 1000 will be k. Why? Because k is less than 1000. Like we are given maximum value is 500. So that's why we can just keep on adding the values, and it will always come as the required value. I mean, we can see one more case also if you are not sure. Let's say a2 is 1000 plus 50. Now x3 is 500. So now a3 will be, we will add 500 to it. So it will be 1000 plus 50 plus 500. So whenever we try to find the remainder of this from here, we will get it as a 500 only, because these numbers are same, and then this is less than the whole value. So it will always come down. And yeah, one more thing which I'm not sure like you folks have noticed is that someone can say, okay, what is the guarantee that AI will always be less than 10 to the power 9? That is a valid question, right? Like what happens, you keep adding these numbers and then the an becomes 10 to the power 10. Can someone give that answer? But if k is divisible by previous number, yeah, so captain, that's the point. We are starting from 1000, so k would never be divisible because k is 500 maximum. It's given in the problem. Yeah, now try to guess like why the value would not go above 10 to the power 9. Correct. Karthik's answer is correct. We are starting from 1000, right? And then we are adding 500 at each element. And total elements are also 500. So at max, we will just go till 1000 plus 500 into 499 element because beginning is that. But yeah, in general, 500 into 500, which is way less than 10 to the power 9. Correct. Vishnu, can you do this? Can you try to do the dry run? And like, if you don't get it, then after covering all the problems, you can ask the question. Then I will like answer that also. Yeah, Tanisha, I can try to do that. It's like not always possible for me, but if people find it useful and overall like sort of feedback it's good, then I can try to do it like more frequently. Yeah, so for this one, Aman, like we don't have to start from 1000. I just took a random number which was more than 500. So let's say you can start from 501 also. That would also work. So like for my algorithm, right, how I explained, so that the k is never divisible by the previous number. That was the goal. So like you can start from 501 also. The same argument will lie. But if you start from 500 and then next number is 500, then you can have it. All right. Let's try to answer this. So it is possible that, all right, let's say we started from 499. So we can choose any value. Correct. Okay, if sound is not, hopefully sound should be okay. Should I increase the sound though? Okay, sound is fine. All right. Cool. Let's go to problem D. And yeah, one thing I want to mention is that let's say like you are just starting up, right? And you could only solve one. Then it is possible that as we go higher in the problems, D, E, F, then like you may not be able to understand like some parts of it, which is fine. If you have solved X problems, then try to solve the X plus one. Try to understand that better because obviously, right? If you can only solve two problems at this point, then if you try to understand the explanation of F, it may be difficult for you because it may be using some concept which you don't even know yet. So like don't worry about those things. Or like let's go to problem D. I think a lot of people couldn't solve D most likely. All right, so I am like I will assume you guys have seen the problem statement. Yeah, so loop x1 is not there. You can take any number actually. Yeah, this is correct. Like D have lot of sort of conditions. I will try to first explain the problem so that it becomes clearer. Yes, fearless correct. All right, so let's first try to understand what does it even mean, right? I mean, so many numbers. If you are just starting out, it's just super confusing, right? You must be thinking, what the hell is this problem anyway? Okay, but yeah, I will try to spend more time on it. Maybe on D, E, F, I will try to spend the most time, and G probably can cover relatively faster. I mean, assuming that folks who are there to understand G, then they would understand faster. But yeah, definitely can take more time on that also. But yeah, let's try to understand the problem. So let's try to understand from the one player perspective. What they are saying is that okay, we are given a permutation T. Permutation means every first we'll just focus on the permutation part. Permutation means every number will come 6 times, one time. Let's say so. Just think our permutation n is 7. Okay. Now just take some random permutation, or we can take one from test cases also if you fix it. I can be good. There's a good permutation there. All right, let's take this from the test case. It is 6 1 3 5 2 4. So in the problem, they are saying that one player will start from one position, and for this test case, they are saying first player start from 9. Okay, let's say no, that is number of turns. Yeah. First player start from position 5. All right. So let's say first player starts from here. Okay. Now at this point, what they are saying is that either this player can stay here or it can move to the next version. Okay. 5 means it is starting from fifth position. So it is starting from here. So at let's forget the second player. Let's forget the problem. At this point, we will just focus about one player. So our goal is that we want to find score of one player. If we can find best possible score of one player, then we are done, right? Because we can do the same for the second player, and then we can compare the score of both of those players to see like who won or if it is a draw. So the choices of both players are independent. They don't depend on one another, right? They just like they do the best possible choice. So like the so like generally, right? These kind of things helps in solving a problem. Like you have to abstract out the concept, which basically means that now I can see right both players' choices are independent. they don't interfere with one another. So I just need to find a score of one player. Then I will do the same algorithm to find like score of second player. So you have to sort of pick. So now the problem changes. Now the problem is not anymore two players who won and all. Problem is just that we are given a starting point, we are given number of turns. How do we find the maximum possible score for this player? Okay. So one thing is that for permutation, thing is, okay, let's say we start from two, and either we stay here or we can move. So let's say in this position we stayed, or next one we move. But whenever we try to move, we can go to the position two, which actually have one there. All right. And then what happens? Then we can go to the one position. Like one position is this, which has six there. After that, we can go to four. After that, we can go to five. All right. That's it. Correct. Okay, that's the scenario. So basically, after five, we are coming back to two. So in permutations, right, because each number is coming one time, we will have set of cycles like this. Let's say if instead of fifth position, we would have started at the three position, then we would have had just this one option. Then there was one option from three, as you can see, right? Third element is three itself. So we would come back at three only. So that's the main idea of permutation which is getting used here, because every point goes to one other point, right? So we will have these cycles. Okay, now we have established this factor that we have these cycles. After that, let's look at, like, let's say you are a person, right? So at every position there is a number which is the array A, which we have. For every position, array A is given. So that's let's say for this problem only, right? Let's take the value 6989510. Okay, at every position, these are the values 6989510. 9510. So in that goal is that I want to maximize my score rate. So if I'm starting from two, if I'm starting from here, what could be the possibility? Possibilities can be, okay, let's say we have one turn, then there's just one possibility. We stay at two, or that's it. We take whatever number was presented in two and we add it to our score. Let's say we had two turns. Then there are two possibilities. One is that we stay at two, so we take whatever is there the second position twice. Or in the first turn we have to take the value at two, but then we decide, okay, I want to move. Then we take the number at one position. Like, are you starting to get the sort of intuition for it? Let's say if we have three turns, then there will be three possibilities. Either I stay at one point forever and I take it thrice, or I go to second point and I can take first one twice, or the second one twice. Okay, let's look at this scenario. We have three cases. Let's say turns is three. So one scenario is that we take first at two, then first position, then sixth position. That is fine. All right. And then one scenario is we stay at two and we take it three times. Then there is other scenario where we take two for two times, and then we take one for one time. And when I'm saying take two, it means the value present at the second position. All right. And by the way, in this problem, we are starting from 5, but let's say we wrote 2 in the end, 2 in the beginning. So you can think that we started from 2. Let me mark that 2. Just put that. All right. So for the situation, we can select 2 times and 1 time, and the other part is 2 1 time and 1 2 times. Now I will make a claim, and then I prove like why this claim is correct. Basically, what I'm saying is that we would never choose this. We would always choose this. Why? Because the goal is that if we would take 2 times and 1 times, then we are saying that second is better than 1, right? Then why would we ever go to 1? Then we will just stay at 2, correct? Because then we can just take 2 3 times and increase our score even more. So out of these two possibilities, this will never happen. This is the only scenario out of those two possibilities, correct? So the like what this argument tells is that okay, we will start from one position, and let's say we start from this 2, and we will go up to some level, which is like at some point, right? Let's say we go up to 6, or we go up to 4, we go up to 5, but we will take every value before that only one time, and all the remaining turns will be spent on the last value. Why? Like I just explained, because like if we want to take any earlier value more than once, then we would take, there is no point of going forward. Okay, I think this, just in a second, maybe let me reload this course. Correct, right? So the goal is that that's the, so this like one argument, right? This is the main argument of this problem. Whether, because like try to understand it even further, like try to solve it on paper. These things matter, okay? I mean, just don't take it on my, like basically if I'm saying just don't take it right away, try to understand it better. In general, like when you're doing problems like this, right? Knowing why this proof works matters a lot. That's why I try to explain it by using this simple example. Because if, if we want to take two times, then there is no value in going forward. Then we just stay there and take that value. So like what we simply do is that for finding the maximum, we just start from 2, and we just traverse this whole thing, and at every position we take, we assume this is the last element. So what we do is that okay, let's say we are at 4 and the turns are 10, then there were 3 elements before 4, like we do some of that, and remaining 7 times we take 4. So we just iterate it once, and then we calculate max of this value. So for all possibilities, let's say we say last element is 6 and turns are 15, we will take 2 ones and 1 ones, and then 13 times 6. Then we go to 4, 1 time this, 1 time this, 1 time this, and 12 times this. Similarly, when we go to 5, 11 times 5. So we take max of all these possibilities, and that would be the maximum score of this flow. So that's it. Like this is the main argument. We do this for both of those players, and then we compare the score. How the order of indices come? Order of indices come from this thing. They are saying either we stay at his current position x, or we move from x to px. That's why if we start from 2, if we start from second position, then either we stay here or we go to 1. Then we go to 1, either we stay at 1 or we go to 6. All right. Uh, Second test case. Yeah, let's try to. We can take a test case for this problem. Second test case. Okay, we can try that actually. What it would be? Hmm. All right. Let me just show you how the loop will be. So, in general, for permutation problems, right? This is super important. Like these kind of cycles. Others, even there is no condition for switching. As a player, you have the choice. That's why we are trying to find the maximum over all possibilities. So we'll assume we will traverse this loop, right? And we will assume that okay, if this is the last position, then what will the maximum score? So we traverse it one and we calculate max over all possible possibilities, and that is the maximum reachable score. Yeah, so this is a good question. I mean, it's not obvious, right? It's not obvious. Why? Because let's say in our loop, numbers are like this: one, one, one. Let's say first number is seven, one, 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 10. So to reach 10, you have to go through one, one, one also. So there can be scenarios when staying at seven and using it again and again. That can be useful. Yeah. So let's come to this part. I mean, turns can be k, right? So, like, do we just keep on going? No, because our loop is maximum of size of n. So there are only n possibilities. After that, we stop by default because there is no more possibility for us to consider. So that's why this will work in linear time. Yeah, this is what do you mean by greedy? Like taking maximum greedy won't work. Like we need to consider all these cases. But yeah, I mean, yeah, so first of all, there are other problems with it also. But the main problem is that k can be 10 to the power 9. So you cannot actually calculate for k turns. Abhishek, uh, can you try to like look at the just like go to the previous timestamp and try to look at if you still don't understand, then in the end we can take it. For this one, maybe we can flash code for some time. But yeah, I let me see. So Kate and Thunder Power 9, right? So you cannot add. And okay, just like if you're a beginner, don't get scared by like code and but just let me try to show the code of it. So this is pretty simple, right? We are not doing anything. We are just reading the input and we are calculating score for both of those things, and then we are comparing the score. This whole thing is the like logic. We are just trying to visit this loop from this starting position, and we update the starting position like this, and at all the positions, right? So sum is the sum of elements till now, and we have this turns minus count, which is remaining positions. Like we are saying, for the remaining position, we'll add the current element, and we'll traverse this loop and consider all the possibilities. And by the way, for all the problems, right? if you want to see my code, there is an option for that. Like you can go to my Codeforces profile and then you can see the code in detail. All right, let's talk about the problem E. Now the after I think E is also like relatively fine, but after these problems will start becoming hard and hard, which is understandable. Like that's the idea of a contest, right? With time and with as we go above, the problems will become difficult. Okay, E, like the statement is super simple, and you must have read it. And actually, like if you see my submissions, right, I solved E in the end. So like this is a construction problem, which basically means that we have to construct a solution. And for these problems, like just wanted to show it because like uh, I could solve G2 also, but still like it took me a lot of time to get the construction. So if you face issue in construction problem, that is completely normal. That can happen because it's a construction. So I mean, it's a possibility that it's not striking you. But yeah, the main part is that if you thought of a construction, then being able to prove it that all right, this gives us the correct answer. That is the key part. So I will try to prove the my construction. Eventually, my construction is very simple, and I think for this problem, like many possibilities are there. Like it is possible your construction is super different from mine. Okay, let's talk about my construction first. Okay, so my construction is very simple. You start with a for 2 by 2. 2 is the minimum n. For 2 by 2, my construction is this. Okay. And then what I do is that, let's say, 2 for 2 by 2, this is a solution. And when we go to 3, I just keep on adding elements here. So let's say we went to 3, I just add an element here. If it goes to 4, I add an element here. So I just keep on adding elements to the diagonal. Why does this work? Let's say for two case, right? For two case, we can cover these things. Just give me a second. For the folks like who want to see the code, like I also tried some construction in the beginning, but then in the end I got this eventually, which is the most simplest thing. That's it. That's the code for it. But getting to it is the difficult part. Okay, so first consider the 2 by 2 case. In 2 by 2 case, how many different values we can get? 0, comma 1. Because if we take this value with itself, then the Manhattan distance is 1, 0, sorry. And then if we take these two together, then the Manhattan distance is 1. So whenever I'm adding this next element, right, what are we adding to the set? We're adding two more values to the set, which is when I added this is 2 and this is 3. It's this. This would be distance between this and this would be 1 to 3, and between this and this, it will be 4. So for 3, we add these two elements, 3, 4. And for the next one, similarly, we are adding diagonal is there, right? So for the case of 4, we are adding two more values, which is 5 and 6. And there is one value between these 2 points. The gap is 2, so we add 2 also. That's it. For the case of 3, we just have these many values, but as soon as we add this one more value, we add 2 also. So let's say we increase it to 5, then we add it to a diagonal. Yeah, so the key idea is that whenever we are adding one element to the diagonal, we add the maximum value with respect to this and maximum minus 1 with respect to the second part. So let's say when our diagonal n becomes 5, we add two more values, which is 7 and 8. 8 with respect to these two, because those two are in the extreme diagonal, and then 7 with respect to the this one, second value. So we add 7 and 8. So for every value other than 3, we will add all of the possibilities. And that's why we know it is a maximum, right? Because we are adding all possible diagonal values. Only for the case of 3, we are not able to add 2. And for everything else, we are adding every possible value possible. We can take general Q&A in the end. Just two more problems are remaining. Cool. This is clear, right? Yeah, I think let's go to F. For F, right, I think F is very interesting. Okay, so this is F. Let me flash it very fast so that you guys can read the statement. For F, actually, there are two parts. Like getting the idea is one part, and then actually like how to implement the idea in code. That is also not straightforward. So I will talk about that also a little bit in this. Okay, so in the end, they are given these queries, and it's asking whether that array is interesting or not. Interesting definition is it. All right. So let's get started. Okay, so first of all, let's say we have this array from A1 to AN, and we are given this L to R. So we are considering this array. First part first. Let's say this first we want to find the XOR of these XOR of elements between these two. Let's say if that XOR is equal to 0, then what will be the answer? Can anyone try to think? Just this simple point. If elements, if the XOR of subarray L to R is 0, then what would be the answer? Yes, correct. K is equal to 2 would always work, because why? So you can split this at any point now. You can split this here, and you, you don't even have to, so like, think about it actually. Like, you don't even need to worry about it. You can just split it at any point and it will always work. Why? Because the total ZOR is zero. So that's how ZOR works, right? Total ZOR is zero. So if we split it at any point, whatever the ZOR of this left part is, ZOR of the right part will also be the same. Correct? That's why if it is zero, then we don't care. We just say yes, this is interesting area. Because overall is zero. So let's say the ZOR of this part is K, then this part, let's do a different number. Don't want to let's say this is W, then ZOR of this part will also be W, because the total needs to be zero. So the other half also have to be zero, because ZOR of the same elements is zero. Correct. So now let's forget the case. It's zero, then it's fine. And general case would also solve this scenario. But yeah, let's assume now it's not zero. Okay, so now we know ZOR is not zero. What do we do now? ZOR is not zero. Also, yeah, and that is okay. Now I'm making a claim. Let's say ZOR of this is W. So my claim is, now the whatever part we want to do, every part ZOR will also be W. This is my claim. Why? Because let's say we made three parts. So every part have to be same. Like, the problem is asking us ZOR of every part have to be same. So if it is Z, then total ZOR will become Z, because ZOR of Z and Z is zero, and then it will remain. So like, whatever the ZOR of this part is, total ZOR have to be that. Otherwise, like, in the end, total ZOR will come as Z. So because of this claim, the ZOR of every part have to be W as well. That is the main idea. After that, we are done. We just need to, then the implementation part is there, which we'll talk about right now. So after this part, right, the main thing remaining is that given L and R, can we do this? Is it possible to split it? One idea is that, which is very often used in these kind of scenarios, is that for every value we store the like prefix array for ZOR, which is like, let's say for one second. Cool. Yeah. Can we do communities and check if the ZOR is visited before? Hmm. Correct. This is correct. Mhm. That idea is correct. Basically, what we can do is we store the uh, prefix ZOR, which basically means that for ith value, ZOR of numbers from 1 to I. That's it. So we store the prefix ZOR in a map or something, and then we want to search. How, like, what do we search for? That is the point. I want to search whether in L to R is there a first prefix which can make ZOR up to W. So let's say the ZOR of part before this. Let's say ZOR till here is K. So if this is K and we want to search for W in the part after L, then what we can search in the prefix array is we can search for K ZOR W, because in that we want to remove the first part from. So we can search for K ZOR W in the prefix array. And what is the technique to solve these kind of scenarios? That we can store all of these values in map. Let's say we have three, we can have a map which stores all possible positions for that pre-zone. Let's say pre-zone is 6. We can have a map which stores a vector of 1, 5, 7, 8. So now we can just binary search in this vector to find out, okay, if L is 4, then what is the first value from this? And then we need to do the similar thing from behind, like from R also we want to find out, because at least 2 elements we need, right? So in the similar way, in this, by using the same vector, we find one value from R also. And then if, let's say after 4 we found 5, and then R is 7, we try to find if there is something before 7. If that is 5, more than 5, then we know for sure that, okay, at least 2 array we have. So like 2 subarrays we can split into. Then we don't need to care about the middle one, because if we can find 2 subarrays with ZOR W, then we know whatever is present in the middle, their ZOR have to be W. Why? Because the total ZOR is W. Cool. Let's go to the last problem. Yeah, I mean, obviously, naturally, that is difficult, but I will try to like, and I think very few people will be interested in knowing the solution of last one, but I will try to go through it very fast. Okay, so this is the G1 problem. In that, like we are in this one, L is equal to R. So we are given this K, basically value of K, and we want to find the maximum possible LCP. Okay, so first of all, what we can do, we need to pre-compute an array, which would be super useful for this problem, which is, you can say, you can call it LCP array. And like how to calculate it very fast, there's a standard algorithm called Z function. You can use that. Captain coded how many you solved. Like in case you solve 3 or 4, that is okay. I mean, tough problems, it would be hard for you to get, which is fine. Don't get like threatened by it, basically, which is completely okay. It takes time. Like you can improve gradually only. All right. So for G1, the idea is that we pre-compute Z function, which is Z algorithm, which is an algorithm to pre-compute this LCP function. What this LCP would tell us is that, so LCP I will tell us the common prefix between the first position and the ith position. That's it. So now we will assume that we have prepared this LCPI, and Z function can be used to actually calculate this one. Okay, so after that, how we do it then? Okay, let's say I tell you answer is X. Let's say I tell you X is the maximum value. And we just want to check whether X is the answer or not. Like we are going from behind, like we are going in reverse. We know X is the given and we want to check whether X is possible or not. What we will do is that is simple. Because the first sub array is fixed, right? It will always start from first position. That's why we will start from first position, and then okay, if it is X, then we start go to the X index, and after that we see okay, if LCP of this position is greater than X, then we can start the second subarray here. If not, then we keep moving forward. That's the idea. Let's say if this is again okay, LCP of this is 1, which is less than X, then we go to second position. At some point, we will find one more value where LCP is, let's say, X plus 1. So we start the second from here, and then we increment it by plus X again. So that's the idea. Like if we can get more than yeah, by if using X, we can get more than K subarrays, then we can say this can be the answer. Correct. So by using this, we can actually check what will be the answer, right? So now after after that, we can just do binary search for the solution. I mean, this can be uh, sort of scary for the people who don't know it, but it's just a binary search, and at each point we need to check whether this value works or not. If this value works, then we try to go to the right half. If the value doesn't work, then we try to go to the left half. That's the solution for G1. For G2, we go in one more reverse direction. Just let me fix this. For G2, we need to consider like it in a little bit different way. So instead of calculating the now in the G1 rate, we're calculating for a L what is the maximum answer. In G2, we calculate reverse. What does that mean? We say that okay, count is we say that maximum prefix that is possible is, let's say, C, and we want to find out like how many maximum subarrays we can make from it, and then we use the like same approach. We find this from 1 to n, and the main idea is that okay, by looking at it, it may look like okay, it is n square, but that's not the case, because every point we are moving, if we are checking for C, every point we are moving by plus C plus C plus C while doing our check. So for the when C is 1, it can take n time, but when C is 2, it will take n by 2 time. For 3, n by 3. This is compared to like how we do C for the prime number. So it will, that's why like it won't be like quadratic. Like if you want to understand about the series, then you can check out Sieve actually, which will be very interesting. There is one point which I missed, or like you guys must be wondering whether we are at one position. Okay, if the LCP is not greater, then we are traversing it one by one, right? So how does this work? N by 2, n by 3. Yeah, this part is difficult for, so like at any position, we want to calculate very fast, which is the next number, which is greater than, for that LCP is greater than this. For that one, we can use segment tree. You can have a look at my code for G2, like how I use it. We will use segment tree to find it fast, so that this n by 3, n by 4, all these things can be maintained. So what we can do is, yes, what we can do is for every candidate prefix distance, We start from 1 to n. Let's say for 1 we found out that answer is C. For 2, for 1 we found out that answer is, let's say, 2. 2. We can do it at max group of 2, or more groups, let's say. We find that now just look at one candidate. We find that for one, answer is 7. We can split it into maximum 7 parts. And for 2, when we try, we find that okay, uh, yes. So in the end goal is this: for 1, let's say it's 7. For 2, 2 means maximum prefix is 2. We can split it into maximum count of 5. For 3, let's say this is 3. For 4, this is 1, let's say. So what we do is that now we traverse it from back. Okay, it will be reversed basically. Okay. So for like one candidate distance, right? When we have it, when we have candidate is equal to 3, and we know we can split it into 10 parts, then for all the values lower than that, from 1 to 10, we know the answer is at max, like at least 3. So we calculate this for all candidates, and then we just iterate the array once, and then we take the maximum. That is the answer. So like we don't even care about L2R. We just calculate this value from 1 to n for all possible cases. Like if you quickly want to see what I mean by that is the code logic is here. For all candidate, we calculate this, and then we keep on storing it in our answer, and then eventually we traverse it from the reverse, and we know, okay, for this count, what is the maximum answer? No idea about the segment tree, which is fine, Kishanjan. Then this problem is not for you. Like at least at this point, you need to focus on the earlier problems, and then after that you can like look at the harder problems. This is fine. Like don't worry about this. Like the growth is gradual only, so don't worry much about it. Cool, cool project. Not clear the implementation. Searching unique F fleet explained with code. Tanish, can you do this? You try to look at my code for F. I will share my yeah. I will connect my submission page in the description. You try looking at my code, and then if you don't understand, comment on the video. I will answer there in detail. That would be the best purpose. If there is any, sorry, first I need to know these those. Correct. We can talk for like 5 minutes more, then we will close. If there are any questions about something specific we discussed today, or if there are any general questions also, that we can discuss in like next 5 to 10 minutes. Let's say we can close at 12. So yeah, next 8 minutes, if there are any questions or something, we can talk about those. Yes, I can share my portfolio. Yes, so this is my Profiling, yeah, actually, it's my submission. So you can find submissions of all the poems from here. Yes, Arindam, this is correct. Like in general, right? In contest, you have to think about this meta strategy also. Meta strategy means, okay, if some problem is like for me also, right? Today, I solved A, B, C, D, then F, G1, G2 after that E. Because in E, I was feeling I was not getting it instantly and it was wasting a lot of time of my mind. So in general, yeah, in contest, you have to consider like these kind of meta things basically. Okay, I mean, if it's not working, it's useful to like, if you are stuck in a problem for let's say like 20-30 minutes and like it's not the hardest basically according to your level you have solved the harder problem before then try to read the next one because I mean sometimes it can happen that you can't solve third problem but you can solve fourth so it makes sense to read it. How to get logical problems like E? Yeah, so that is difficult definitely. I mean there is no one general solution is that the answer is that more and more practice of these problems. And in general, okay, one part is getting the idea like how we want to do the construction. That part is by definition difficult, and more by more practice, you have more thoughts in your head, and probability of getting to idea increases. But then the second part is, which is if you got the idea, then proving whether your idea is correct or not. That part can be built by generally like in any kind of scenarios trying to look at the proof in general like building your like logical reasoning and those things will help. So for that part never skip the proof, always try to understand the proof. Like in many problems today also, right, I made some claim, I said okay, this I'm making this claim why this is true. Never miss the why. That is the most important. Just Ronak, I have plans to do that either string or DP. Like either of those two, I will try to cover first. Either dynamic programming, in which I will cover like problems on CSS and try to sort of explain the normal standard problems from there, or the string one. Either I will take in like as a first. I will try to make like a competitive programming playlist of let's say 5-6 videos or something like that. Yeah, so Deepak, we would have like daily problems and contests in the camp actually. So you would have enough material to like work on the at least the CP part of it. So that should be sufficient for that time period because I don't think you will get like more time. Project one is strings placed, lots of replace. All right, I will try to cover it. One thing I felt Pratik was that I mean like I was considering string, but not that many people are interested in string, and string algorithms are relatively harder for people to understand. So, like I felt people are not that interested in it. But yeah, I'm considering that. Even let's say in case I do DP first, then also I will do the string. Those are hard for me. All right, all right. Yeah, if you're part of the camp, then at least the model and all those things, some things we will try to cover. So communities in general, like CP algorithm website is there, right? Personally, I like that website a lot. I mean, like personally, I have learned many like advanced algorithms from there. So, like personally, I strongly recommend it. Hopefully, guys, the session was useful. Yeah, this is the first time me trying to like live stream the editorial session, and yeah, hopefully this was useful. Like based on like how many people watch it or something like that, then we will consider like how frequently these can be made. Obviously, time is a constant, so that is there. But yeah, I think we can close now. Okay, guys. Bye bye. Hopefully, it was useful